All right, guys, hi, welcome to Thursday. I don't know if you can see me, or you can't see me, I have no idea. But this is the first video, hopefully it works out. The first video is gonna be your homework. What we're gonna do is we're gonna go over the two problems that were in the book, which were number 119 and 121. So hopefully this works. Here you go. And hopefully you're having a good day. I hope you're not in bed. Butanedium, a component of butter and body odor, has a cheesy smell. Elementary analysis gave the following percent composition: 55.80% carbon, 7.03% hydrogen, and oxygen was 37.17%. The molar mass is 86.09. Molar mass, 86.09 grams. And then it says determine the molecular formula. Find molecular formula. Now, there are different ways of doing it. You can go directly to molecular formula, but I'd like you to try doing the empirical formula first, and that way you'll know how to do empirical formula. So the first thing we need to do is we need to three steps. Find a number of grams. This is easy. 55.8, because percent we can just change it to grams. Second step, change it to moles. So we've got 55.80 grams of carbon, 1 mole, 12 grams, gives me 4.646 moles of carbon. Hydrogen, 7.03 grams of hydrogen, multiplied by 1 mole over 1.01 grams, gives me 6.96 moles of hydrogen. Finally, 37.17 grams of oxygen, 1 mole, 16.00 grams, gives me 2.323 moles of oxygen. Now, I want to go mole to mole ratio. Which is the smallest? Smallest is oxygen. So I'm going to go 2.323 moles of oxygen into 6.96 moles of hydrogen. That's going to give me, what is that? 3. 2, 4, 6. 3. So it's 3 moles of hydrogen for 1 mole of oxygen. I'm going to do the same thing now for carbon, which is 4.64 moles of carbon divided by 2.32 moles of oxygen gives me 2 moles. 2 moles of carbon for every 1 mole of oxygen. So I'm going to end up with C4. Whoa, what have I got wrong here? Oh, C2H3O. C2H3O. That's my empirical formula. Now, to find the molecular formula, I'll take the mass, the molar mass, which is 86.09, divide that by the empirical formula mass, which is going to be 2 times 12 plus 3 times 1. I'm not going out to correct sig fig, sorry. Times 6 plus 16 And that gives me 16, 17, 18, 19, 19, 29, 39, 42, 43. 43 grams. So it's 86.09 divided by 43. That's easy. It's 2 to 1. So I'm going to double this, my empirical formula. I'll get C4H6O2. All right. Now let me just check to make sure you can see what's going on there. I think you can. That was the first problem. Beautiful. All right. Let me just erase this. And of course you can stop the tape anytime you want. And let's do the next problem. Okay, here we go. I think it's 121. 121 says, nicotine, the stimulus has the mass per composition. The molar mass of nicotine is that. It's the same type of problem. But what I have is, let's see, I have 74.03 of carbon and 8.70 of hydrogen and 17.27 of nitrogen. The molar mass is equal to 162.26 grams. Okay, here we go. I'm not going to do, we know we're going to say these are grams. Let's change them into moles. If I divide this by 1 over 12, I'm going to get 6.164 moles of carbon. Remember, keep this as many sig figs as possible. It'll be helpful. The next one, I'll multiply it by 1 over 1.01, which gives me 8.61 moles of hydrogen. 1 mole over 14.01 gram gives me 1.233 moles of nitrogen. Now I've got moles, I gotta go mole to mole ratio. This is nitrogen is the smallest. I'll divide that into each one. 6.164 moles carbon divided by 1.233 moles nitrogen equals, that's a tough one. 6 nitrogen, huh? Wait, nitrogen, that's carbon, I'm something like 5. So 5 moles of carbon for every 1 mole of nitrogen. And then let's see what I got here. I got 8.61 moles of hydrogen divided by 1.233 moles of nitrogen. And that gives me, what does that give me? That gives me 7. Whoa, 7 moles of carbon, 1 mole nitrogen. Remember, you can round a little bit. Now, so that will give me, my empirical formula becomes C5, C5H7, and the mass of that is going to be 81.12 grams. So to find my molecular formula, I'll just take the molar mass, 162.26 grams, divided by the empirical formula mass, 81.12 grams. That's 2 to 1. So that means my molecular formula will be C10H14N2. Okay, let's look at the molar treasure hunt. Beautiful. Let's look at the molar treasure hunt. I'll erase this. And I cannot see if you guys can see. I hope you can see, because if you can't see, it won't be much fun just listening to what I'm saying. So hopefully you can see. My head's probably chopped off. A mole treasure hunt. How many moles of sulfur atoms have a mass of 128 grams? How many moles of sulfur atoms have a mass? So I got 128 grams. 1 mole, the molar mass. And then the answer is going to be how many moles? And the answer is 4 moles. I think I don't have the molar mass of that. I think it's 32 grams. Number 1. Let me get my periodic table here. All right. Number 2. What mass of 0.1 moles of calcium carbonate? What is the mass? All right. Calcium carbonate, the molar mass of calcium carbonate is equal to 100. It's about 100 grams. So if I have 0.10 moles times 1 mole over 100 grams equals 10. These all are going to be whole numbers, or close to whole numbers, because this is for a treasure hunt. Number 3, how many moles of silver contain that many atoms? 3.01 times 10 to the 24th, and then it's going to be 1 mole over 6.02 times 10 to the 23rd, and that gives me 5. So this is 1, 2, 3. Let's look at 4. What is the mass of that many molecules of sodium bromide? So 6.43 times 10 to the 22nd. Change that to moles. 1 mole is 6.02 times 10 to the 23rd. And then we're at moles, multiply that by the molar mass. And I believe the molar mass is, I don't know what the molar mass is. Sodium bromide, whatever that 1 mole times the molar mass. And the answer to that is, I think, 11. Oh, what is the mass? Let me let me look at the mass of sodium bromide. Mass of sodium bromide. NaBr. Na is 22.98, I believe, and bromine is 22.98, close. Bromine is 79.9. So 8, 9, 10, 12. It's about 102.88. So that's number 4. Number 5, how many grams of chromium are present in 0.25 moles sample of chromium 3 phosphate? Cr, chromium 3, 3 plus, PO4, 3 minus. So it's just, we just got to take the molar mass of that, 0.25 moles times the molar mass, 1 mole, molar mass. And the answer to that for number 5 is 13. Okay, let's go to clue number 6. I'm going to erase this. Clue number 6. Hopefully you guys are getting this. This is good for review. Really good for review. Okay. Number 6. How many moles of iodine atoms are in the empirical formula of a compound that contains 93.27% iodine and 6.73? We got to find the empirical formula. So number 6, let's find the empirical formula. 93.27%, change it to grams. 1 mole divided by the molar mass of iodine, which I believe is 126.9. And then I have 6.73 grams percent, which will change to grams of manganese. And that's 1 mole over 54.9 grams. What do I end up with? I end up with 0.73 moles of, what was that? Iodine, and 0.122 moles of manganese. Divide 0.73 by 0.122, and I end up with M and manganese or magnesium? Magnesium, manganese, Mn. MnI6. So the answer is 6. Number 7, how many moles of oxygen atoms are present in 2 moles of lead sulfate? How do you write the correct formula? PbSO4 2. Because it's lead 4. Look at the Roman numeral. Lead 4. That means it has a 4 plus. SO4 is a 2 minus. From there, 2 moles, pretty simple. That's going to be 8. I got 8 oxygen in 1 mole. So I'm going to have 16 oxygens. Iron nitrate, number 8, contains that. How many grams of oxygen will be present in a 7-gram sample of the compound? What is the formula? The formula is FeNO32. Iron nitrate, Fe3O2, contains 53.77, so it's 53.33% of oxygen by mass. How many grams of oxygen will be present in 7 point? So I have 7.50 grams of this whole thing. Now all I have to do is find out what is the percentage of oxygen in that. So what is the, if it was a, let's see, 53.33% oxygen. Oh, so they just told me that. Oh, how good is that? So I just multiply by 53.33. Well, it's percent, so it would be point. So it would be 0.5333. And that would give me whatever the answer is, which I believe is 4. Number 9, what is the percent by mass of hydrogen in ammonium hydrate? You gotta know how to write these. And that's gonna be NH4OH. What is the percentage by mass of hydrogen in it? Well, I've got 5 hydrogens, so it's going to be 5 times 1.01 divided by the entire mass, which would be 14 plus 1 plus 4, 4 of them, plus 16 plus 1. Okay, that's 10, 20, 30, 35. What is the percent by mass of hydrogen in ammonium hydrate? Percent. Oh, 35. So it ends up becoming 14%. That makes sense. Okay. Number 10. How many moles of water molecules are in an empirical formula of a hydrated sodium carbonate if a 4.3 sample has a mass of that after heating to complete dryness? Beautiful. All right, let me write this down here. This is similar to the lab we did. And let's see what we got here. Okay. How many moles of water are in the empirical form of a hydrated sodium carbonate? Sodium carbonate, Na2CO3 dot question mark H2O. if a 4.3 gram sample, 4.3 grams, 4.37 grams of the whole thing has a mass of 1.85 grams after heating. So this is going to be my water. So that's going to be my water. So I've got this much water, and I've got 4.37 minus 1.85, which will give me my Na2CO3. So now I divide, that's 2, 13 from 8 is 5, 3 from 1 is 2. So I got 2.52 grams of Na2CO3. Now, what do? I change it to moles. 1 mole divided by 18 grams. 1 mole divided by 106 grams. 106 grams. My number might be wrong. So for some reason, let me just see. 185. Wait, 185 grams. How many grams of the hydrogen mass? Oh, my bad. It said this is going to be, whoa. This is going to be, this is wrong. 2.52 is the grams of water, because what was left was 1.85. So it was 2.52 grams of water left that we lost, and 1.85 was how much of the anhydrous that was left. And after doing this, how many moles of water, our empirical formula, we're going to find that we got an 8-to-1 ratio. 8-to-1 ratio. Go here to here, and then those moles will be 8-to-1. And then a compound is made of 80% carbon, 20% hydrogen. What is the empirical formula? You guys do that. It's got to be CH3. Compound, what is the empirical formula? And what is the mass of that? The mass is 12 plus 3 is equal to 15. So, a lot of work, but really good review. So hopefully this worked out. And I'm going to finish this right now and then take a break. You guys don't have to take a break. Go on to the next video.